Hello, my name is Samuel Garay, and in this video I am going to talk about the genese of hydrothermal deposed. Okay, to start, is necessary to know that hydrothermal deposed. Okay, they are those formed for solution coming from the consolidation of a magma and also by the circulation of aqueous solutions in the air crust which can be constituted by primary magmatic waters or by a mixture of these with meteoric waters. Therefore, deposits can be formed in connection with magmatic hydrothermal systems related to deep to intermediate plutoniums, this between 500 to 3000 meters, and with meteoric magmatic hydrothermal systems linked to volcanic and subvolcanic complex, depths between 100 to 1000 meters. The hydrothermal waters can be juvenile, magmatic, metamorphic, cognate, and meteoric. The juvenile water diabsisting in the mantle. Magmatic, the one coming from the consolidation or cooling of a magmatic melt. Okay, metamorphic, those originate from the dehydration of minerals during metamorphism. Cognate, water trapped during the deposition of sediments and subsequent diagenesis. Meteoric, they are those that can filter through the air crust, reaching these were heated and enriched in elements linked in this path that acquire hydrothermal characteristics. Similar seawaters can be penetrate the reaches in the ocean crust to great depths, where a convection cell is produced with discharge on the seabed. The composition of solutions. The main ingredients of hydrothermal solution is water, pure water. However, cannot dissolve metals. Hydrothermal solutions are all with brightness, containing dissolved salts such as sodium chloride, potassium chloride, calcium sulfate, and calcium chloride. The salinity range varies from seawater about 3.5 percent to about 10 times the salinity of seawater. Such brightness are capable of dissolving small amounts of elements such as gold, silver, copper, lead, and zinc. High temperatures increase the effectiveness of brightness in dissolving metals. Okay. Origin of solutions. The hydrothermal solution waters can be derived from magmatic sources, meteoric water, groundwater, and seawater. Some hydrothermal solutions can also be produced by regional metamorphisms during partial wet melting. The water that causes the melt is released when the magma solidifies. This water carries with its solvent constituents such as sodium chloride as well as gold, silver, copper, lead, zinc, molybdenum that do not really enter the compositions of common minerals. For example, quartz or feldspar by ionic substitutions. The meteoric and seawater can also form hydrothermal solution if they are sufficiently heated and the convection system is generated. The resource of the heat is magmatic intrusions, so magma is a key ingredient in the generation of hydrothermal mineral deposits. Hydrothermal mineral deposits are those associated with the divergent and convergent plate boundaries. Hydrothermal deposits die from today. In this In this example, you can see three: the Imperial Valley, South California, the Red Sea in the East Pacific rise. The Imperial Valley, Southern California, in 1962, um, uh, this was the first unequivocal evidence that mineral deposits can form from hydrothermal fluids. The Red Sea in 1964, the oceanographics discovered as a series of those brightness at the foots of the Red Sea. Okay, in the East Pacific rise in 1978, submarines over the ancient Pacific at 21 north found hot springs as 300 centrical digers emerging in plumes along in the mid-ocean ridge 2,500 meters below sea level. The minerals precipitate as soon as they emerge of around the chimneys while the banked of salty minerals. This is an analogous modern example of the volcanic massif's sulfides deposed. Okay, mesothermal depth 1.2 to 1.5 kilometers, temperatures 200 300. Occurrence generated in the near intrusion igneous rocks associated with regional faults, extension replacement deposed or fractured fillings, tubular bodies, stockworks, and pipes. Metals, ore, silver, copper, blende, molybdenum, nickel, etc. Hypothermal depths 3 to 16 kilometers and temperatures to 300 and 600. Occurrence in or near deeps satin, felsic plutonic rocks in deeply crowded areas, fracture films on replacement bodies, tabular on an irregular shapes, metals, copper, lead, zinc, silver, ore, golden. That's it. Okay, thank you.